In this example, we're going to use the mesh analysis to find a I0 in the network. So this is about a circuit with shared current sources. When I say shared current sources, it means a current source that is shared between the meshes. For example, this 4 milliamp that is shared between this mesh and this mesh. So for this type of problem, we know that there are two different ways to solve it. So the method 1 is a supermesh method. The method 2, that is called a general loop method. So we're going to use the two methods to solve the problem. So method 1, supermesh method. So when you use supermesh method, we define the mesh current similar in the regular way as how we define the mesh current. So we will define the mesh current. So I will define this as my mesh current I1, this as my mesh current I2, and this will be my mesh current I3. Step 1, that's what we did, define all the mesh currents. And step 2, write mesh equations, sometimes loop equations. For the first mesh, we have 3 plus 2 times I1 minus 2 times I2. And then we also have a voltage increase of 12, so minus 12, that is equal to 0. Between second mesh and the third mesh, we have one constraint, because the current going through this branch has to be 4 milliamp. The current going through that branch will also be represented by I2 minus I3, that is equal to 4. We can only write these two loop equations. The third equation will come from this supermesh. So the supermesh are obtained by assume that we don't have this shared current source. That will open up another mesh, which is this one we are going to indicate by using the dashed line. So this will become a mesh. This mesh is called supermesh. So we use KVL to write this loop equation. So the voltage drop on this is 3K resistor, that is 3 times I2. The voltage drop on this 2K resistor, that is 2 times I3. The voltage drop on this 1K resistor, that is 1 times I3. The voltage drop on this 2K resistor, that is 2K times I2 minus I1, that is equal to 0. This is how we obtain these three equations. Then step 3 is to solve the equations. We get I1, that is 10 over 3 milliamp, current I2, that is equal to 7 over 3 milliamp, and current I3, that is equal to negative 5 over 3 milliamp. With all this mesh current, we can solve for I0. So this will lead to the conclusion I0, that is simply I1 minus I2, that is equal to 1 milliamp. We're also going to use the second method to solve the problem. The second method, general loop method. So step 1, define loop currents. So we're going to define my I1 the same as this current I1. My current I2 is the same as the previous current I2. And we're going to find another loop instead of the mesh I3 as my current I3. So I'm going to define my current I3 this way. So this is my current I3. Step 2 is to write mesh or loop equations. It's important to pay attention that the first equation is also different from the first equation in method 1 in supermesh method, because the current going through this 2K resistor, that is different now. The current going through this 2K resistor, that is composed of 3 parts, I1, I2, and I3. So let's write the loop equation for the first mesh. Let's start from this 3K resistor. That is 3 times I1 followed by this voltage increase, so we have minus 12, and then the 2K plus 2 times the current I1 minus the current I2 minus I3. So this becomes the actual current going through that branch with a 2K resistor. So this will equal to 0. The loop equation for the second loop, so because there is a current source over here, the current in this branch has to be 4 milliamp. So by giving the mesh current that we defined, the current going through that branch is also I2. So we have a I2 that is equal to 4 milliamp. The equation for loop 3 is a little bit more complex compared to the rest. So let's do it one by one. We start from this 3K resistor. So that is a 3 times. So it's important to know that the current going through this 3K resistor is composed of two parts. So I2 and I3. Since I2 and I3 are in the same direction, we have a I2 plus I3. The voltage drop on this 2K and 1K resistor plus 2 times I3 plus 1 times I3 plus 2 times this 2K resistor times I2 plus I3 minus I1, that is equal to 0. Now step 3, we can solve this equation. We can find I1 that is equal to 10 over 3 milliamp, I2 that is equal to 4 milliamp, and I3 that is equal to negative 5 over 3 milliamp. Now we can get the conclusion. Step 4, I0 in this case, that is I1 minus I2 minus I3, that will give us 1 milliamp.